Hi everyone and welcome. My name is Billy and today we're going to look at the idea of an expected number. Now, to think of an expected number, we're going to first go back to our definition of probability. So the probability of any event A is the number of times that thing occurs over the total number of times. This is quite intuitive because the numerator is the number of things that you are interested in and the denominator is simply the total number. You will see us using n as the letter that always refers to the number. So on the numerator, it's the total number of things you're interested in, and on the denominator, it's the total number. Let's take this formula and rearrange it, and this time we're going to make this numerator the subject of our new equation. So we're going to write NA is equal to the probability of A multiplied by the total. And this bit here, NA, we refer to as the expected number. And we write it as a capital E, A. This ends up being a pretty simple formula to remember, so that the expected number is the probability of A multiplied by the total number. Let's see how this works in real life, because this has really very many practical applications. Here's our first example. The supermarket around the corner sells your favorite cereal. The weight of cereal in each box is shown at 450 grams. The cereal manufacturer says that the probability of getting a box with less than 450 grams is 0.02. The manager orders 1,500 boxes. How many of them contain less than 450 grams of cereal? So the situation looks like this. Each box says that it has 450 grams of cereal. The manufacturer has told you that the probability that the box actually weighs less than that is 0.02. The supermarket manager has ordered 1,500 boxes, so they really want to know how many of these boxes will have less than 450 grams because they don't want their customers to complain that there's not enough cereal in the boxes. Let's write down our formula for the expected number. So the expected number of something is the probability of that thing multiplied by the total. The probability is 0.02 multiplied by the total number of boxes, which is here, 1,500, and the answer is 30. The way we explain this is that out of the 1,500 boxes that the manager orders, we can expect there to be 30 boxes where the weight is less than 450 grams. 30 boxes will have weight of less than 450 grams. Let's take a look at a second example. Tom sleeps past his alarm and misses the school bus one day in every 2 weeks. In a semester of 10 weeks, assuming there are no holidays, how many times does Tom miss the bus? When you have a problem like this where there really aren't so many numbers, you're not actually given a probability, we'll need to reread the question and see what information we can get. The first sentence, Tom sleeps past his alarm and misses the school bus one day in every 2 weeks. So that gives us a first bit of information. 2 weeks, let's multiply that to get the number of days. So there are 5 school days in a week, that's 10 days. So Tom misses the school bus one day out of every 10 days. So the probability that he misses the bus is 1 out of 10. in a semester of 10 weeks, assuming there are no holidays, how many times does he miss the bus? 10 weeks, let's convert that to school days. So that is 10 multiplied by 5 days a week, so it's 50 days. So that means that our N total is equal to 50. All right, this is looking a little bit easier to handle now. Let's write out our formula for expected number. So the expected number of days that he misses is equal to the probability of him missing the bus multiplied by the total number of days. The probability of missing is 1 over 10, multiplied by the total is 50, and my answer is 5 days. So this means in the whole semester, Tom misses the bus 5 days out of the whole semester. I hope these examples have been useful for you. Thank you for stopping by to watch, and I'll see you next time. Bye for now.